Hey guys, I'm very excited for another episode of the show about science. This is your host, Nate. Today on my show I have Brianna and Sarina, together the Amoeba Sisters. There's 2 chapters. First we're going to talk about how the show got started, and then we're going to go to some science questions. Hello, Brianna. Hello, Sarina.
Hi.
I've been listening to your channel since I was 2 years old.
Oh, my goodness. Well, I am so excited to finally get to talk to you because it's just been really neat listening to your podcast.
So, when did you decide to make the Amoeba Sisters?
So I'm a teacher, and my sister, she actually works for a school district, and we both wanted to find a way that we could make the things that we talk about a little bit more easy to understand and also kind of fun. And we like to use a lot of things that we think are funny. So we just decided that we would just try to make a video together, and it seems like some people started liking it, so we just decided to make more of them. We have such a great time doing it.
And plus, I've always liked the illustrations.
Oh, I'm so glad. I've got a kind of a crazy imagination, so there's some fun stuff. Bree is kind of our content expert, and then I'd like to take what she says and try to give it a little bit of life.
I think one of the first Amoeba Sisters that I ever saw was the one on viruses.
Oh, yeah. We think they are really interesting. You know, one thing I got to do for science fair when I was a kid is I got to do an experiment with a virus called the nuclear polyhedrosis virus. And it was a virus that went after insects, and it attacked them. And so it would go after insects that were really pests, these insects called waxworms that go after beehives. And it was really interesting because it would attack these bad insects, but it was very selective, so it wouldn't go after some of the good, healthy, helpful insects that are helpful for our crops. So it was really neat. It was something that I got to experiment with when I was in 9th grade. I know you're in kindergarten, so it'll be a little while before you get to 9th grade, but maybe something to look into, you know, if you've got a neat interest with viruses.
What kinds of diseases and different types of viruses cause?
Oh, okay, so viruses, I love viruses because they just as far as how interesting they are, they have this ability to kind of hijack cells. They cause things, for example, like the common cold is caused by a virus. And the cold virus, you know, it's so interesting. When we get colds, a lot of times we want to take all these medicines, but really antibiotics and a lot of medicines that work like antibiotics, they won't really be very effective for a virus because viruses, we need our immune system to be able to clear them out because antibiotics are not very helpful for those. Also, the influenza, which is the flu, there are vaccines that can help prevent against many viruses, and so they're important for things like the flu. But once we have the flu, those antibiotics are not very helpful. They're usually for bacterial types of disorders.
So, what about the viruses that go after your immune system, like HIV and Ebola?
So HIV is what makes this virus very difficult and tricky is that it goes after our white blood cells, the very cells that we need to protect our body. And so when it goes after those, our immune system is so weakened because we almost have no way to defend ourselves. And so if you get something else, like even the flu, which normally people are able to fight off the flu, but if you have the virus HIV, because your immune system is so weakened, it can be very, very dangerous. Now, there are medications that they are researching and working on that can help try to stop those viruses from attacking immune cells, but they're still kind of in the process of working with those types of medicines because it's so hard. Those viruses tend to mutate a lot too, and that makes it hard to come up with medicines that will work.
So, how does bacteria and viruses destroy the cell membrane?
Well, so bacteria, when they attack cells, a lot of times they have toxins in them that they can actually release that can destroy cells. And some bacteria, they will feed on healthy cells and destroy them that way. Viruses, on the other hand, they inject their genetic material into the cell. So they start to replicate, and then they'll break out of the cell. And when they do that, that will destroy the cell membrane. If it's the type of virus that does this cycle, the lytic cycle. There's other viruses, though, that are sneaky, and they stay stuck in that cell, and then later on they might switch and go into the lytic cycle where they will just pop out of the cell. But those types of viruses that go after cells and do the lytic cycle, they will actually destroy it by just reproducing so much in the cell.
How do cells replicate their DNA?
You know, it is so neat how this works. So basically cells, they're always in this cycle, the cell cycle. And at any given time, there's some time in this cycle. And during part of the cycle, they actually do DNA replication. And it's when they make more DNA so that they can divide. And so they replicate their DNA in this phase of the cell cycle. It's called the S phase, and that's where they duplicate it. And they have to do that before they can ever divide.
So, what happens if a cell fails its checkpoint?
That is a great question. So if it fails the checkpoint, maybe it didn't grow well enough, or maybe there's something wrong with the DNA, it has to actually destroy itself. And Sarina, you had a great picture for how you did that.
Yes, I did. I wanted to make sure that when they were trying to get past that cell point or that checkpoint, that they couldn't get past. And we had a big stop sign, making them go through all the different checkpoints and making sure that they're duplicating their DNA, that they're growing and doing all their cell regular activities.
So if they can't make it through, they're supposed to do this apoptosis, where they destroy themselves.
So what happens if the cell keeps going when it was supposed to self-destruct?
That is a really good question. So if it makes it past the checkpoint, if it sneaks by, and we're still not really sure what makes it get by, there's different ideas on how it's escaping, but once it gets past one of those checkpoints, if it can get to the mitosis stage of the cell cycle, then it can divide, and any cell that comes from that cell will carry that problem if the problem was a mutation in the DNA. So they'll have that same problem, and if they keep dividing over and over, before you know it, you have this uncontrolled cell growth. They just grow out of control. And unfortunately, this can lead to diseases such as cancer, where it's uncontrolled cell growth.
How does a cell divide?
So cells have phases that they go through in a process called mitosis. And in mitosis, they have these different phases where they have to get their DNA into the new cells. And that's really the most important thing, is that if you're going to divide, you've got to get the DNA that you have into the new cells so that they can divide well and make sure there's not any mistakes. So when they divide, they go through these stages: prophase, metaphase, anaphase, and telophase, where they take their DNA in the form of chromosomes and put it into the new cells, and then they split. And it's in this fancy word, cytokinesis, where they break up across their cytoplasm, and then they make these new cells. And so that's kind of their process for how they do this. And it really is important that the cells in mitosis, that they end up the same as the original cell. So they have to be identical. There shouldn't be any kind of mistake.
How do you make a copy of chromosomes?
Well, what's interesting about chromosomes is that they're actually made of DNA and protein. So when you're copying chromosomes, you're really copying the DNA, and that's during that S phase of the cell cycle. So what's kind of interesting is that the DNA, in order to be able to be transferred easily, it condenses, it thickens into chromosomes so that it can be moved around. But it's getting duplicated during S phase, because that's when you're actually replicating the DNA. And it sounds like you really have a lot of interest in cell division. Is this something that you've been really interested in, Nate?
Well, I have been interested in a lot of things about the human body.
Oh,
Wow,
yeah, and
really
this is such an important part.
Yep. So I look at a lot of shows that include some things about cells and DNA. What does RNA do?
So RNA is also in our bodies and on our cells, and RNA is involved with protein synthesis. So the thing is, the DNA, even though it codes for our traits and tells our body what kind of things we need to be able to make, you have to get that message out to your cells so they can make protein from the DNA in order to do that. So RNA is this great kind of like a messenger. If you have mRNA, that's a type of RNA that takes the message from the DNA. And then you have rRNA, and that's a part of a ribosome that's involved with making proteins. And you also have tRNAs, which actually bring the amino acids. And I know, Sarina, you have always drawn those kind of neat.
Yep, there's so many different types. We kind of give them some different personalities. Like messenger RNA, that's the one that actually gets to leave the nucleus. So DNA is kind of trapped in there, but messenger RNA is kind of like a little postal carrier. It takes the DNA's copy out to the ribosomes, and tRNA, they're kind of like, I like to think of them like as little fighter pilots, like coming in with the amino acids and creating proteins. It's kind of like a little cell city inside our bodies. It's really neat to think about.
Ooh. So if you want to find some Amoeba Sisters videos, then go to YouTube or amebasisters.com. Thank you, Brianna. Thank you, Sarina.
Thank you
so much, Nate.
It was
We had such a great time
talking
talking to you.
There you have it, folks. The show about science is complete. Then you can shut the recording off.